On September 23, 1992, the United States conducted Divider, an underground test at the Nevada test site, which is now called the Nevada National Security Site. The test, designed and executed by scientists at Los Alamos National Laboratory, was the nation's 1,054th and final nuclear weapons test before the current testing moratorium. Divider marked the end of an era that began with the Trinity test. 30 years later, the National Security Science magazine team paid a visit to the Divider test site. We traveled with a group of scientists who had been involved with underground nuclear testing to mark this historic anniversary. I'm Brenda Fleming, and this is the National Security Science Podcast, a spin-off of Los Alamos National Laboratory's National Security Science magazine. We bring you stories from the lab's weapons program, stories that show how innovative science and engineering are key to keeping America safe. This episode marks the second installment in our three-part series on nuclear testing. Today, we'll focus on Divider, the final test. Before an underground nuclear device test could take place, there were months of careful planning, negotiation, and collaboration. As the scientists gathered to recognize the 30th anniversary of Divider, they remembered the cooperation that testing required.
Before we ever came here, we were going to Oak Ridge Y12, looking at the materials as they put them together, checking to make sure it's what we think it's going to be.
Sandia provided components, Kansas City, Y12, Savannah River, so they would all come together, typically partly in Pantex, and then a lot of the final assemblies were done out here before transporting out to where the test was going to be.
Planning and preparing for a test was a major collaboration that started at least a year before test day.
It isn't just the day of the test. You think about what the test will be, and that's, at least a year in advance that you're thinking of that. And then months and months in advance, you're inspecting the parts that are going to go down hole, the nuclear parts, the nuclear physics package parts, making sure that it really is what they say it is. And that's several months in advance you're doing that.
Today, what remains of the Divider site is a shallow crater surrounded by a forest of Joshua trees. But 30 years ago, visitors to the site would have seen a tall tower built to hold the rack, a giant metal structure that would contain the nuclear test device and multiple pieces of diagnostic equipment used to study the explosion and its effects.
The tower would attach to bolts, just as you see on the steel plate. The corners have bolts, and you tighten the nuts, and you start building the tower. Typically about 130 feet, 150 feet, depending on the length of the rack.
The rack could be as big as 10 feet in diameter and 100 feet tall. Scientists would set the rack up in the tower and install all the equipment and the cabling.
So the rack would come from Los Alamos. It was built in Los Alamos. Typically it was hung in Los Alamos, right, in a tower. We would go to Los Alamos and do dry runs of diagnostics.
When the rack was ready, scientists lowered it into the ground. Holes for underground testing were sometimes as deep as 4,000 feet beneath the surface. That's a hole more than twice as tall as One World Trade Center in New York City. The last step was called stemming, a process of filling in the holes around the test rack with layers of material to prevent radiation leakage. Scientists had to understand the geology of the area where they were testing to determine how to stem the test shaft.
And sort of the layers are, at least in part, the design is informed by the geology up the shaft, because it's not all like this down the shaft. There are different layers of different types of rock and sand, and the stemming takes that into account in order to minimize the chance of gases getting out.
After months of preparation, the day of the test arrived.
It's all culminating in this, but there's a whole lot of people throughout the whole complex that were involved to get that, and at each point you check it, and that's why when it's insertion time and it's your last time to pray over the nuclear package, it's because you've actually been doing that for months and months before to get it to that stage.
Shot Day was the day the test was conducted. The nuclear device was detonated.
So were there a lot of nerves on shot day, or were you
Oh, yeah.
feeling calm?
I don't remember ever being calm on a shot day.
It was so exciting to actually work on a nuclear test. It's just absolutely mind-boggling. And the really cool thing is everybody who's working with you, we were all pulling for the same thing, right? I mean, the camaraderie, the teamwork, the excitement, and then you were all put to the test simultaneous.
The scientists marking the anniversary explained that an underground nuclear test follows a particular sequence of events. First, the nuclear device detonates, creating a shockwave that emanates from the device.
See a groundswell,
Okay.
and the diagnostic trailers that are close to ground zero are on special grids that mitigate the shock from the ground into the trailers. And you can watch those move.
In less than a second, the container of the device and all the rock around it are vaporized, creating a cavity where the detonation occurred.
Just see like a crater form.
Well, yeah, the crater can take several hours.
The shock wave travels beyond that of the cavity, crushing rock until its force decreases and it dies out. A few seconds later, the molten rock around the detonation cavity settle in the bottom of the cavity, where it begins to cool and solidify.
And for the really big shots, then there's a ground shock that actually makes it up to CP. And the experts that were out here for lots of shots could tell from the ground wave what the yield was.
For dividers, some people at the control point. Some of them stood in doorways so they could feel the shake. I remember looking at I guess it was microphones from the ceiling hanging, and they're just sitting still, but all of a sudden they start swinging.
Next, the gas created by the pressure of the detonation begins to decline, and the rock around the cavity collapses. Finally, a chimney is created by the progression of a rubble column up through the hole in the surrounding geological material. This last event usually only takes a few hours, but it could take up to several months. Once the test has stabilized, scientists can retrieve their diagnostic equipment to study the data from the explosion.
In a sense, everything is an electronic signal recorded somewhere, but there's a level at which you don't want to know just the electronic signal. You want to know what it meant in terms of the physics of what happened down there. Some things would literally take months to know how well something worked. You might know you had a signal relatively soon, but you wouldn't know what that signal really meant. You would know you got data.
And it's a physics challenge, right? Geophysics. Of just how do you pick the hole? How do you put it there? The tremendous engineering. What was it like for you guys on shot day? You've got all of this, and folks forget how expansive the amount of science that was going on for one of these tests was. But in the end, it was to see whether you got it right.
When the moratorium took effect, a lot of people were saying, well, now we're going to take all that money that we spend on testing, now we can go do real science. As if what we had been doing wasn't science. There's an incredible amount of science in diagnosing one of these experiments.
Divider was never planned as the final nuclear test. Rather, Divider just so happened to be the last test conducted by the United States before a short-term testing moratorium went into effect on October 1st, 1992. Several months into the 9-month moratorium, the Clinton administration extended that moratorium indefinitely, and here we are, 3 decades later.
On the day, did you know it was the last test?
Oh no.
On the day of the test?
We knew a moratorium was coming, but there was talk of at least another 10 or 15 shots after that. And the 2 laboratories were negotiating on what those tests were going to be.
As it turned out, Divider would be the final test conducted before the current test ban was enacted.
The good thing about Divider was that it performed better than we predicted. Not a bad way to go out.
Driving back from the Nevada National Security Site, my colleague Whitney and I discussed how we are most likely the only people from our generation to have stood on ground zero of the United States' last underground nuclear test. Looking back in history, we contemplated the significance of the divider test and the end of full-scale testing. Today, instead of nuclear testing, the United States relies heavily on non-nuclear and subcritical experiments, coupled with advanced computer modeling and simulations to evaluate the health and extend the lifetimes of America's nuclear weapons. Los Alamos National Laboratory is playing a key role in carrying out these experiments, and one of the places this work is taking place is the Nevada National Security Site. Join us for the next installment of this National Security Science podcast series to explore subcritical testing. And don't forget to check out National Security Science Magazine online at lanl.gov/magazine to learn more about how better science equals better national security. For more great stories from Los Alamos, including several other podcasts, video series, and interactive stories, visit discover.lanl.gov. That's discover.lanl.gov.